In this presentation, we have to talk about the ground state of the Deuteron. The Deuteron consists of a proton and neutron. It is a weakly bound system since its binding energy is 2.225 MeV with a negative sign. The only bound state of the Deuteron is the ground state. If you increase the energy of the Deuteron from its ground state, then the Deuteron is separated into its constituent proton and neutron. We assumed that the orbital angular momentum quantum number of Deuteron is L equal to 0 and the spin angular momentum quantum number S equal to 1. This means that the spins of the proton and neutron are parallel and the system is in the triplet state. This is triplet state. Here 3 represents the multiplicity factor 2s plus 1. This 1 represents the total angular momentum. S indicates the orbit corresponding to L equal to 0. L equal to 0 corresponding to S orbit. If you consider this triplet state 3s1, J equal to L plus S logic is satisfied. L equal to 0, S equal to 1, so L plus S equal to 1. Total angular momentum is unity. But actually, to describe the ground state, not only the S state is sufficient, we also need the D state. Consider mu suffix P and mu suffix N are the magnetic moments of the proton and the neutron respectively. We know that Deuteron consists of a proton and neutron. If you consider the magnetic moment of the Deuteron, that should be equal to the sum of the magnetic moments of the proton and the neutron. But actually, mu p plus mu n minus mu d is not 0. It is having some value. This represents the Deuteron is in the triplet state and some other state. The other state is D state. Here 3 represents the multiplicity factor, 1 is the total angular momentum, D denotes the orbital angular momentum quantum number, L equal to 2. In this case, the system is considering the logic of J equal to L minus S. The total angular momentum J equal to orbital angular momentum minus spin angular momentum. 2 minus 1 is equal to 1. And another one problem is, suppose a system is spherically symmetric. The electric quadrupole moment of the system, that means spherically symmetric system, should be equal to 0. But in the case of Deuteron, we are having some electric quadrupole moment. Therefore, Deuteron is not purely spherically symmetric. By considering that the central potential describes the Deuteron in its ground state, the Schrodinger equation in the center of mass system is given by equation 1. Here mu is the reduced mass, that is equal to mass of the proton into mass of the neutron divided by mass of the proton plus mass of the neutron. We know that the mass of the proton is almost equal to mass of the neutron. Consider the mass of the proton as capital M, then we can get mu equal to m by 2. If you replace mu by means of m by 2, we can get this equation 2. Here del square is our Laplacian operator. If you express the Laplacian operator in spherical polar coordinates, we can get the equation 3. The solution to equation 3 is psi of r theta pi equal to psi of r into psi of theta comma pi. Using the method of separation of variables, we have to solve this equation 3. Therefore, replace psi by means of psi of r into psi of theta comma pi and take out the constant terms outside. See here, this is dou by dou r operator and is allowed to operate on psi of r. Therefore, psi of theta comma pi is a constant. We have taken it out. Here, dou by dou theta is operating on psi of theta comma pi. Therefore, psi of r is a constant. We have taken it out. Here the dou square by dou pi square operator is operating on psi of theta comma pi. Psi of r is a constant here, taken out. Here no operator is present. write down the terms as such. Entire is equal to 0. Now divide all the terms of equation 4 by psi of r into psi of theta comma pi. Then you may get this equation 5. Multiply equation 5 by r square. Then we can get equation 6. Then align the r terms and keep them in the left hand side, and then align the theta terms and shift them to the right hand side. You can get equation 7. In equation 7, left hand side is a function of r, whereas the right hand side is a function of theta and pi. Therefore, the left hand side should be equal to a constant L into L plus 1. Here L is our orbital angular momentum quantum number. Now multiply equation 8 by psi of r by r square. Then we can get 1 by r square dou by dou r square dou psi of r by dou r plus m by h cross square e minus v into psi of r equal to L into L plus 1 psi of r by r square. Now bring this term to the left hand side, then the right hand side is equal to 0. Furthermore, take out this m by h cross square as a common term, then we can write e minus v minus of L into L plus 1 h cross square by m is r square, entire is multiplied by psi of r is equal to 0. In the case of ground state, the value of orbital angular momentum L is equal to 0. 1s state is the ground state, L equal to 0 corresponding to the s orbit. Then if you put L equal to 0, the equation 9 is modified in this form. This term is cancelled out. Now this dou by dou r operator is allowed to operate on these two functions. U V formula we have to follow. If you take this r square outside as a constant term, r square cancelled out, then dou by dou r of dou psi by dou r is dou square psi by dou r square. Then keep this dou psi by dou r as a constant term, differentiate this r square with the help of this operator dou by dou r. Dou by dou r of r square is 2r. Then 2r by r square is 2 by r. And write down this term as such. This is equation 11. Substituting psi of r equal to u of r by r in equation 11. Just dou by dou r of u of r by r. This is u by v form. We have to apply the u by v formula. Then find out the second order differentiation. Dou square by dou r square of u of r by r. We can get this equation 12. Just replace psi by means of u, rinse out this term, then m by h cross square e minus v into u of r equal to 0. If you do the operation, we can get this equation 12. This is the essential equation to describe the system entirely. We represent the potential V of r by a square well of depth V0 and width R0. See, this is the square well potential of depth V0 and width R0. Here R0 is the range of the nuclear force. R, the x-axis represents R. R is the separation distance between the proton and the neutron. At R less than or equal to R0, see this condition, R less than or equal to R0 means the system is considered inside the square well potential. So the potential value V equal to minus V0. We are talking about this region, V equal to minus V0. Now consider this equation. If you replace V by means of minus V0, this is taken as E plus V0. Then E, the total energy, should be replaced by minus E suffix B, that is binding energy. Binding energy is negative. Therefore, the equation 12 is modified in this form. Dou square u by dou r square plus m by h cross square into V0 minus EB into u of r is equal to 0. Consider this is k square. So, dou square u by dou r square plus k square into u equal to 0. Then k equal to root of this quantity. The solution to equation 14 is u of r is equal to a sin kr plus b cos kr. Now we have to talk about the condition r greater than r0. That means outside the range. We are talking about the nucleons in the region of outside the box, outside the squirrel potential. See here, at R greater than R0, the potential value is 0. Say, if V equal to 0, this is dou square U by dou R square plus ME by H cross square into U of R is equal to 0, but E equal to minus EB. Therefore, dou square U of R by dou R square minus MEB by H cross square into U of R equal to 0. When R, that is the distance of separation between the nucleons, is greater than the range of the nuclear force, the potential value is 0, then the equation is modified in this form. Put the value of MEB by H cross square by gamma square, then 16 is modified in this form, where gamma equal to root of MEB by H cross square. Here Ma is the mass of the proton, EB is the binding energy, H cross is our H by 2 pi, Planck's constant divided by 2 pi. Now the solution to this equation 17 is U of R is equal to C in T power gamma R plus D in T power minus gamma R. Here is a negative sign is present, so that we are writing the solution in the exponential form. To find out the values of the constants, we have to apply this condition. The value of psi of R is finite at R equal to 0. At the origin, the wave function is having some value. See his potential. At this point, the wave function is having some value. Suppose R approaches infinity, the wave function is vanished. That's the meaning for this statement. Now, the value of psi of R is finite at R equal to 0 and 0. That means the wave function is 0 at R approaches infinity. From equation 15, here put R equal to 0. U of 0 equal to A sin K0 plus B cos K0. What is the value of U of 0? U of 0 equal to 0. How do you say U of 0 equal to 0? See, this psi of R is equal to U of R by R. U of R equal to R into psi of R. If you put R equal to 0, U of 0 equal to 0 into psi of 0. At the origin, psi is having some value, but 0 into anything is 0, therefore U of 0 is 0. Say U of 0 is 0. We know that sin 0 is 0, cos 0 is 1, therefore B equal to 0. Now the solution, U of R equal to A sin KR plus B cos KR becomes U of R is equal to A sin KR. Now take this equation. Now we are considering this equation at R equal to infinity, R approaching infinity. That means U of infinity equal to C into e power gamma into infinity plus D into e power minus gamma infinity. U of infinity equal to 0, because if you put R equal to infinity, psi of infinity equal to 0, 0 into anything 0, automatically U of infinity equal to 0. E power minus gamma infinity equal to 0, but e power plus gamma infinity equal to 1, therefore C equal to 0. Now the solution becomes U of R equal to D into e power minus gamma R. At R equal to R0, both psi of R and its first derivative must be continuous. See this case. At R equal to R0, then consider this solution. A sin KR0 should be equal to D e power minus gamma R0. Then take out the differentiation, first order differentiation. Sin KR0 equal to cos KR0 into K. E power minus gamma R0 is e power minus gamma R0 into minus gamma. Now find out the value of 22 by 21. We know that sin by cos is tan, but cos by sin is 1 by 10, that is cot. Therefore, K cot KR0 equal to minus gamma. Then the value of K is this much. Cot trigonometrical function, once again the value of K, then R0, which is equal to minus of the value of gamma. experimentally measured value of R0 is 2.1 Fermi. By substituting the values of R0, E suffix B, M, the mass of the proton, and H cross, we can get the value of V0, that is the depth of the potential value is 36 MeV. Now we have to find out the value of K. K equal to M by H cross square, V0 minus EB. M is the mass of the proton. H cross is H by 2 pi. Planck's constant divided by 2 pi. But the value of H cross square by M is equal to 41.3 MeV femtometer square. Then K equal to V0 36 minus EB 2.225 divided by 41.3, because H cross square by M is 41.3. M by H cross square means you have to divide 1 by this quantity. So that if you simplify, we can get 0.90 femtometer per minus 1. The maximum value of the wave function is given by the equation sin kr equal to 1. Sin pi by 2 equal to unity. Therefore, kr equal to pi by 2. The value of pi is 3.14. Therefore, the value of kr is equal to 1.57. You know the value of k. Kr by k equal to r. Then r equal to 1.57 divided by 0.9, that is equal to 1.744 femtometer. This means that the wave function is having its maximum value at a distance of 1.744 femtometer. See here, the total width of the spiral is 2.1 Fermi. The wave function is having its maximum value at a distance of 1.744 femtometer. See this value exactly, 1.744 femtometer. See, this is almost the total width is 2.1. The maximum wave function is attained at 1.744 femtometer. Hereafter, the wave function is going to decrease. Therefore, we may say that from the value of r equal to 1.744 femtometer, it is evident that the wave function has its sweep outside the well, indicating the deuteron in the weakly bound state. Furthermore, the deuteron size is defined by 1 by gamma. If you calculate the value of 1 by gamma, the value is 4.3 Fermi. The obtained size of the deuteron, that is 4.3 Fermi, is twice the range of nuclear force, and explain the fact that deuteron is a weakly bound system. That's all about the ground state of deuteron.